Hello physics students, this is a quick video to help you with force problems in one dimension. So over here on my screen I've got a little situation with an elevator and a person riding in the elevator, and the person is accelerating upward with an acceleration of 2 meters a second squared. The mass of the person is 100 kilograms and the force of the floor is what's asked for. So remember that we write Newton's second law like this: the acceleration equals the vector sum of the forces over the inertial mass, and that is also equal to F net divided by the inertial mass. So if we want to find the floor, and we know that the object is accelerating, the force of the floor, then we can rearrange this equation, and we can say that ma must equal the vector sum of the forces. And that must equal, I go to look at my diagram to figure out what the vector sum of the forces is. Force of the floor is upward, so I'll make it positive, minus force of the earth. So when we say vector sum, that means you have to include the direction. So we're not always adding, we're subtracting in this case because the earth is downward. So this is a negative direction, this is a positive direction. And that's why I say you can look at your diagram to figure out what to write here. So then I could just plug in numbers and I could come up with an answer. So if I plug in numbers, I've got 100 kilograms times 2 meters a second squared equals the force of the floor minus, notice that the force of the earth on an object is the mass in kilograms times 9.8 newtons per kilogram, minus 980 newtons. So then I have 200 newtons equals force of floor minus 980 newtons. Obviously, the force of the floor must equal 1180 newtons. Does this make sense? Well, let's look at the situation. The person in the elevator is accelerating upward, so the force of the floor must be greater than the force of the earth on them, or they would not be accelerating upward. And the force of the earth on the person must be 980 newtons. So yes, that makes sense. Checks out. Hope this helps. Remember, what one fool can learn, another can.